We're good? Okay. Hello, everyone. Welcome to the Intro to Golang workshop. Intro to Tech. Is this the last Intro to Tech for this semester?
Yep.
Yeah, so this is the last one of the semester. Thank you guys for pulling up and being here. I sent a link to like the setup guide or just general resources on Discord. It's under the announcements channel. It's going to be like essentially this. It's going to tell you how to set it up. All you need to do is just download and install Go for your respective like OS. So just go and download it. It shouldn't take long at all, like 3 minutes at maximum. And then it's just like general how to run like a Go program. And then more resources. I'm going to post the slides after this workshop on this Notion page, but there's just like resources and stuff if you want to learn more. Since I'm just going to preface that I'm not like an expert on this topic. This is just something I thought was cool and something that I was able to work with over the summer at like a professional level. So, and I thought it was really cool. I thought it was really nice. Go is such a nice language. Like truly, it's wonderful. If I could code in anything for the rest of my life, it would either be Python or Go. So yeah. But we can just get right into it since we don't have like that much time. So first up, if you're here, then you're an ACM member. Well, you can just go over what ACM is. ACM UTSA is the #1 largest premier tech student organization at UTSA. We have over 2,000 registered members and a decade-long presence on campus. We focus on creating a community for any and all students interested in technology to connect, learn, and grow. We host the big events like Rowdy Hacks, Rowdy Datathon, Code Quantum, and Rowdy CyberCon. It is completely free to join. We do not charge any dues whatsoever. And if you attend 5 events a semester, then you get grad gear and then invite to the end of your banquet. If you're graduating early, then it's going to be the semester that you graduate. I mean like that fall semester then. And this QR code is to register as a member. If you are already not registered, this will take you to our registration portal. You just type in like your ABC123, a email, don't use your UTSA email. And yeah, you should just be able to sign up and check in for this event. So if you're not already registered, there it is. And then here's the check-in for the event. If you're already registered as an ACM member on our membership portal, this is the check-in. You can just scan this QR code and it'll give you the points. So I'm gonna leave that up there for like a minute so you guys can get that. Grab the wall there. Okay, everyone's got that, I assume? Yes, you guys are good? Okay, cool. We can just move on. Let's get right into it. So, what is Go? Oh my gosh, I had a picture here, but I guess it disappeared. So Go is a high-level general-purpose language that is statically typed and compiled. It's not like programs like Python or anything because it's compiled. And it was developed in 2007 by engineers at Google, then later released as open source to the public in 2009. It's known for its speed and simple syntax. It's used a lot for building like web servers, APIs, CLIs, DevOps stuff, cloud infra. It's like a backend catch-all, if that makes sense. Like it's used for a lot of backend stuff in the modern day. It's really nice because it is syntactically similar to C, but it also has garbage collection, so you don't have to like if you malloc anything, you don't have to go and like clean that up after. It just does it for you. There's more information. I'll have more information on the garbage collection a little bit later. And it has structural typing and then CSP style concurrency. That's also why it's like used a lot for like web stuff, and it's used a lot for backend and like highly scalable systems because it has a lot of concurrent features just built in. Like you can do a lot of stuff with concurrency just built in, like right off the bat. And so yeah, there's like the cute little gopher guy right over there. I think in like 2009 is when they had the mascot. And it was like, just TLDR for Go, it is developed by Rob Pike, Ken Thompson. It's super fast, super scalable, and very simple. So that's why a lot of big tech companies like to use Go. So yeah, let's go into some more history of Go. Oh man, my freaking pictures did not load. But Go is designed with 4 core principles in mind. It was developed with static typing and runtime efficiency like C and C++. Readability and usability like Python and Ruby. And high performance for networking and multiprocessing. I don't really know why Canva does this, but it like always adds like spaces in between the words. I don't know. Yeah, something weird with that, but yeah, it's like for high performance, and the developers did not like C++, so they said, watch this, let me do it better. And then the Gopher mascot did not come around until 2009 when they launched the language as open source. You guys saw the Gopher mascot. And fans of the language are typically called Gophers. Yes. And so why Go? Why do people choose Go? We can just go into like, it's fast and it makes things very simple. You can, like your programs will run fast and you are also able to develop fast because it is so simple. So that makes it like optimal in all fronts really. Go is engineered for speed at every stage of development from one line of code to deploying at scale. And so we can just go into like more specifics. It was compiled to native machine code, and what that means is like Go is a compiled language, and so it's code that your CPU understands directly. There's no interpreter, no virtual machines, or like middlemen. Like Go, if you compare it to Python or like JavaScript, which is interpreted line by line at runtime, Go does not need any of that. You just hit run and it goes. So yeah, and then it has super fast compilation. So being compiled is great, but sometimes a lot of compiled languages are slow to compile, like C++ or Rust. The Go developers made sure that super fast compilation was a priority. And I don't know like the specifics on like the build processes, but it is very simple and insanely optimized. So that's why a lot of people opt to use Go. It has efficient garbage collection. So Go uses low latency, non-blocking garbage collection, which kind of works in tiny slices instead of stopping everything for a few milliseconds, which allows the program to keep running and results in memory management with minimal lag. So, and then stuff with Go routines. Yeah, so Go routines are Go's like lightweight threads. I don't know if you ever worked with like Java threads or anything like that. It's like a way to, this is more like concurrency and like parallelism stuff, and like running programs in parallel. But yeah, Go routines are like Go's way of running threads. They're super cheap and you can spin up to like thousands, millions of them and not really use that much memory. Like it's only a few kilobytes of the stack. And yeah, this just in general makes Go extremely good at handling concurrent tasks like web requests, background jobs, and data pipelines. And this is why it's chosen by so many big tech companies. And moving on to the minimalist standard library. So Go's standard library is very small, but it's also very powerful, and you don't really need to waste time installing like 50 different packages or figuring out like which third-party library is best because it's already like built into the standard library. They have a lot of stuff, so it's just really nice to have it all compact. And then for no class hierarchies, no inheritance overhead. So many like object-oriented programming languages like Java, C++ can get bogged down with like deep class hierarchies and like a lot of abstraction. But that's where like Go excels because it kind of just skips that. There's no classes, inheritance, it's just structs and interfaces. And if you're unfamiliar with structs, it's kind of like a way to essentially make your own type, like declare your own type. I'll show you more examples of like structs and how it's used in Go, but it's, if you've worked with like C programs, it's very similar with the way that structs are used. And it's very super simple, and it is designed for composition over inheritance. And it's just in general like makes everything easier to optimize. So yeah, I included the little Gopher guy. He's very fancy here. So some more information on the different types. These are all the types that Go has. Just general like numbers, booleans, like integers. It has pointers as well, so essentially everything that like C has, Go also has, which is really nice. The strings, like all this stuff. And then some more information on the types. Strings are immutable, so that means you can't like modify them after you declare them. And then like if you want to work with strings, it's a lot of like built-in operators and keywords, and like as opposed to using functions to like modify the string. They let you concatenate strings, compare them, and like all that other stuff. Record types can be defined with the struct keyword. Again, yeah, you define structs in the same way in like C, where you just like say struct this. And I'll give more examples. I'll give more examples soon. And Go has like pointers. Very cool. Cute little model sheet right here. They have like a little like art design sheet for the guy. I think, what does that say right there? It says like when he's sitting like his body flesh folds in half. That's very silly. I think that's so funny. And then there's like, they show like the 2 different ways that he can hold things. He can hold things like that or like that. Then there's 2 little cute ones on the side. And then just in general, like this is the syntax for variables. This is like all the different ways that you can define a variable in Go, but most people don't do that. You usually want to use the alternative. This is the one that everyone uses. You just say like message, it like makes it, initializes and like declares it and like fills it with a value with hello, and then you can also do that here. But yeah, everyone uses this bottom one, so you don't really need to do all this stuff up here. This is just flow control. This is general how to do like an if statement, general if statements. You don't use like parentheses, but you definitely want to use like braces. Use braces for everything. You can omit parentheses for literally almost everything in Go. So yeah. Syntax for for loops. Here in this one, first one, again, omitting the parentheses. Like if compare it to like Java, it's very similar syntax-wise, Java and C. So for count, set count to 0, go up to 10, increment count by 1. And then format.println. Format is like a package that you usually want to import because it's like I/O. It lets you do I/O stuff, like input-output stuff. And so yeah, just println, my counter is at count. And then over here we have n, set n to 0, x set to 42. If n, like for n does not equal x, then just, this is assuming we have like a function that returns a number that's just guessing. And then just keep doing that. And then here's just like how to loop through a list, or a list. They have slices, more on like slices in Go later, because slices is a little bit complex. But yeah, so we're just gonna loop through the range, like loop through the entries. We have Vivian, Jabril, and Trey. At index 0, the person is Vivian. Index 1, the person present is Jabril, and then Trey. So yeah, and it uses like the similar things to C, where you use format specifiers with like the %d for a number, %s for a string. Oh yeah.
Second example is how you do a while loop.
Oh.
Is that right? That's how you do a while loop in Go?
Oh no, you can also do while loops. You can do all kinds of stuff. It's really crazy. Like you can also do a while loop. This isn't the only way, but it does function effectively the same. It's kind of weird, but yeah, they. Oh, maybe I'm wrong. I could be wrong. But yeah. Am I wrong? Okay. Yeah, so then this is correct. You are correct. And then like a final topic that I'm going to talk about is like concurrency. This is like a very high level overview since, again, I haven't taken like operating systems or anything like that, but this is like to my understanding how concurrency works. I included some visualizations because I'm a much more visual person to like understand topics. And so yeah, this is kind of how concurrency works in Go. This is like a Go routine. If I had to explain it, there's like this main loop, and then you create a Go routine, and then it kind of does everything, and then it has it. Oh, hello. And then the red line, like that red arrow, if I could pause it here, I would, but like that red arrow is essentially like a channel. They use like channels for Go, and that's kind of how you like send and receive information throughout the routine, so you can have them talk to each other. This is an example of like how just a basic, like if you make one Go routine, that's how it goes. And then right down here is an example of how you would make a timer. So it's like you have one main thread, and then it's making a bunch of it's making a bunch of Go routines, right? And then they're sending information from each Go routine back. It sounds kind of crazy, and there's a lot more information online. Like I've included some information on the Notion page that's more about this, but you can also find a lot of like textbooks online. This relates more to like computer science theory. But yeah, usually if you use like the Go keyword, then that starts a Go routine, and you can do stuff in the background without blocking the main execution thread. And channels are kind of where you can, again, like what I was saying with arrows, you can send and receive values through that operator, that arrow, and then data flows in the direction of the arrow. And so yeah, does this make sense to everyone? Because I have like some more information, but concurrency is still stuff that I try to wrap my head around. It's kind of crazy. But yeah, concurrency is like one of Go's biggest strengths, because you can run it very simply. It's just with the Go keyword. You guys are good? You guys want to move on to examples now? Okay, cool. Let me figure out how to change my screen. Share screen, window, screen one, share. Okay. Okay. So here we just have a main.go. We don't have anything in main.go. I assume you guys have already installed Go and you're all ready to start? No? Oh, yes, yes. You do also need the VS Code extension for Go. It might like automatically ask you to do that, but yes.
Can you download the website?
Huh?
The website?
Yes, I included that on like the Notion page, so you can just go in there and like download it and install it. And so yeah, we can just like go and start right ahead. Let's just make a quick like hello world. We're just gonna say package main. This is our main everything. And then import. We're gonna import format. This is like IO stuff. This allows you to work with IO, so like strings and like all of that. And then let's just in general make our main function. That's gonna be like this. We're gonna make our main function. And then let's just print format.println hello world. And this is just how you make a very basic main.go, and you can either like build it and then run it like C, like you compile it and then run it. It'll create like an executable if you do the build, and so you just have to do / and run your executable. Or you could just do go run main.go. And then boom, it says hello world. That's crazy. That's insane. Welcome to Programming 1. And so yeah, so we can just move on to some more advanced examples. It's just gonna say like, what if we want to, you know, like create a variable? Like, how are we gonna do that? Let's put this in a variable. So let's just say that we have another function. Let's make another function, and it's called greet, our greeting function. We're gonna have a name, and that's gonna be a string value, and it's going to return a string. And from there, like, I don't know, this is kind of weird, but this is another thing I noticed when I was first learning Go. Stuff in Go is kind of backwards. So like name string is a little bit weird, but yeah, that's just something that I had to get used to, and it was a little like jarring at first, but you kind of get used to it, and then like whenever you're reading it, you go, wait, what is that? Oh wait, no, it's like flipped because it's backwards. It's Go, it's backwards. So yeah, it takes a name, and so we're just gonna return a string. So we're gonna say hello, and then concatenate it with name, and then add an exclamation mark, because why not? And so now we need to call it, let's say message is going to be equal to, this like initializes and like adds it. You don't have to do like, I mean you can do the same thing in C where you just have to like make it and then fill it with something, or you could just do it in one line like this. So, and then let's just say greet. Let's give it the name, I don't know, Eric Lee. And then here, let's just, it's giving an error because it's like, oh, we're not using that. So let's just say format.println message. Now it's happy. And I also have like prettier installed, so if you guys have that extension, it makes it really nice and automatically like makes everything look nicer. And so yeah, let's just run that. Hello world. Hello Eric Lee. Very cool, very cool. And so now let's just say that we want to work with some conditionals. So how are we going to do an if-else statement? So for like string comparisons, there's a bunch of different ways you can do string comparisons in Go. Like you can import the strings package and then also like work with that. I think it's library, but you can also import strings and then work with all of the functions that has. But if you care about case at all, like if this is a case sensitive comparison, but you could just say if message is equal to hello Eric Lee. Then you essentially just want to say, let's say if the message is equal to hello Eric Lee, format.println, let's say the message is matched. Let's just say that. And they also have like new lines and essentially like all of the other stuff that you can do in C, you can do here. So like new lines work too. And otherwise, then the message does not match. So we're just going to say format dot parent line message does not match. We're very stern with it. So then, yeah, so this will essentially just like see if the message says hello Eric Lee and it's matched. Otherwise, it does not match. And then let's see, message is matched because hello Eric Lee is what we wrote. And then let's just do a basic for loop example as well. Or let me just write down and comment like this is a conditionals for loop. Okay, so how are we going to do a for loop? Well, let's just do a basic like for I and then set it equal to 0. And then we're going to increment I is less than 3, I plus plus, and then omit parentheses because again, like you don't really need parentheses in Go. Format dot printf. We're going to use printf because we're specifying like a format specifier, counter %d, %d, and then I. And this is essentially, if you're not familiar with like C or anything like that, format specifier is essentially telling you like, okay, so take I right here. It's like giving two things, and then take I and then put that here in %d. And so essentially what this will do is just run a counter. Counter from 1 to or 0 to hold on. New line. Put a new line. Make that look nice. And then here we go. 0, 1, 2. Count 3 times. And so yeah, now we can go and let's do a more like complex example of how how exactly structs work, since I talked about that earlier, but if you're not familiar with structs, then we can just go and do a quick like run through of that. I'm gonna delete all of this. Did anyone need any of this before I delete it? Okay, cool. I'm gonna delete it. And so let's just create a struct. So again, like I was saying, a struct is kind of like building a type, like your own, like making your own type. So let's just say type person struct. Let's make a person. And then we can give them a name that's going to be in the value of a string, and we're going to give them an age, and that's going to be the value of an integer. And so this is like a very basic struct, and you can build like persons, people. Literally everything like in the industry is used like using structs. It's going to be like they'll have like a whole file for like the different structs and then include that file. So like if you're wanting to do anything, like I would definitely look into more like structs, slices, and all that stuff if you want to do more complex stuff. But yeah, let's just make a main as well, a main program to run all of this. And then let's just make a person. Let's have Eric is equal to person. We're going to pass his name. Name is Eric. And his age is 21? Okay, 20. Okay, 20. And now format dot println struct example is going to be Eric dot name and then Eric dot age. And this is essentially just going to print out the information about Eric. His name is Eric and his age is 20. Let's just run that and then we can see that happen IRL. I say IRL. Oh, hold on. I missed something. Wait, after this. Oh, shoot. Wait, yeah, you're right. It's right here. Okay. Wow, struct example, Eric, age 20. Perfect, that's great. And so now we can, this is just how, here, let me write struct example. Let me write down how we're gonna do a array now, because we can just go over how arrays work, since there are arrays in C, but it's, not in C, in Go, but it's not as common as using like a slice. You typically want to use something that's called a slice, and it's essentially like a reference to an array. It's like it lets you take a chunk of the array, if that makes sense, and you can kind of store it. It's not exactly like different than The only difference with the array is that a slice is like dynamic, so you can like, it's dynamically sized, so you can add whatever you want and it changes. An array is like a fixed size, right? And slices are much more common. They're 0 indexed, and then like usually they'll have like a lower bound and then an upper bound, and then they include the lower bound, but then they exclude the upper bound. And so yeah, there's a lot more to know about slices and a lot more stuff, like fun stuff you can do with them. So I definitely recommend checking out like the resources that I linked. Definitely check out like the tour of Go if you're more interested in that. That's like the easiest way to learn all of this stuff, and it gives much better examples than what I'm giving. So yeah. So let's just make an array. Arrays in Go, or just array example. So let's say my array is going to be equal to, let's have 5 elements in the array. It's going to be strings, and we're going to have it say Vivian, Jabril, Trey, Jonathan, and Miguel. Holy Miguel. And so let's just go and print format.println. Let's print out the contents of this array, array example, and then give it my array at index 0. Let's just get the first value, and this will just print the first thing, Vivian. Wow, that's just kind of how arrays work. They're kind of weirdly designed. Like I was saying, like stuff in Go is kind of backwards. So like you see the 5 is here and then string and then the rest of it. It's kind of weird, but yeah. And then let's just go over an example of like how slices work. So let's say my slice is going to be a slice of strings, and it's going to be equal to my array from index 0 to 2, and then again this is including the lower bound but excluding the upper bound, so it's going to be 0 and 1. And so let's just format.println. Let's print out the slice, so slice example, and then we're just gonna say my slice, and this is going to print 0 and 1. So Vivian and Jabril, as you can see, Vivian and Jabril. So 0, 2, yes. And then you can also loop through a slice like this for I, and you can also do this weird thing where like if you're looping through, hold on, let me actually finish this line first. Range my slice. You can also do this weird thing where you can kind of, if you don't care about like your iterable, I'm assuming you're using that right, then you can just add like an underscore, and then it'll just like loop through it anyway. It's kind of weird, but yeah, if you don't really care about it, you can do that. And then, yeah, so then let's format.printf, and then we're going to use the format specifier again, so that's why we're using printf. Names at %d, that's going to be where we want it to go, and then is equal to a string, and then a new line, let's just print out the contents of I, and then n. Yes, okay. And then this is going to go through the slice and print out everything in the slice. And so yeah, these are the names at 0, so 1. Yeah. And so yeah, let's just say that. I mean, I guess this is probably actually, this is pretty misleading. Let me just say it right. This is misleading. So yeah, that's how you loop through a slice. We can go through maps as well, since maps are pretty big. They have maps in Go. Maps are really useful. Let's just make a map of ages. So all these people are going to have ages. Let's just say ages is equal to map string int. So we're mapping a string, so a person's name, to an integer, which is their age. We're just going to say Vivian is mapped to 20. I am age 20. And then let's say Jabril is mapped to 21 because he is 21. And then Trey will be mapped to 20 as well. And so yeah, that's just how you declare a map and make a map in Go. Format.println map example and ages, and just print out the ages. Let's do that. And so yeah, we have our map example, we have a map. Jabril is mapped to 21, Trey is mapped to 20, Vivian's mapped to 20 as well. And honestly, I don't really know too much about like how it automatically like sorts things or lists things. You can look more into that because I'm not really that sure, but it's seeming to automatically order by age. And so yeah, you can just access it in the same way if you access like anything else. So like you can just access it like format.parentline, and then we're just gonna say Vivian's age is whatever, and then ages at Vivian. That's really it. And so that's how you would just access like one thing from the map. Oh, what the heck? Okay, yeah. And then my age is 20. Yep. So that's just general like syntax stuff for Go. Does anyone have any questions about like this? And if you're more curious about this stuff, all those resources are on Notion, so like it's pretty good. I would definitely recommend like the best ones you want to look at are the tour of Go, and also there's like a roadmap. I think it starts with an E. It's like X or something. That one's also really good. And then there's also like if you're confused about syntax, there's like I included a cheat sheet for the syntax. Because that's all you really need to know. If you know C, then you can pick this one up. Yeah. And so again, like noting why this is better, you don't have to like clean up any of this stuff. It's like unlike C where you have to clean up all of it. You don't really have to do any of that. So yeah, we can just go over how to do concurrency now and like how just an example of concurrency if you guys are cool with that. Oh, what's up?
Does Go have like a dynamic array? Like things I can push and pop?
Yeah, so you'd probably want to use a slice for that. You could like declare a slice of that and then do that, but arrays itself you can't really like. They kind of annoy me. I don't like arrays.
So how would it, like if I wanted to add a new name to my array, how would I do that?
Yeah, so let me look that up. But it's like I think it's just like .add or something like that. It's very, very simple. Hold on, we can look that up right now. Oh shoot. Slice and go. Appending to a slice, you just append. And this is the tour of Go. I would totally recommend checking this out, if anything, and like walking through this since, yeah, there's like 10 pages on slices because there's so much to go over with slices. But yeah, you just append to it. And yeah, you can append nil stuff. It's crazy. But yeah, you can make slices of slices too. This stuff's crazy, but this is how you would do it. Yes.
For appending to the slice with the array, like how does that work?
Could you clarify?
Yeah, okay, so the array we have, it has size 5.
Yes.
Is there, like, in Python anyways, a slice is like viewing a specific like subarray?
Yeah, so essentially like it's kind of, you can put slices into like variables and then modify those. Like to my understanding, you can't do that to arrays. Like you can't just like append to an array. You would just have to make a slice of it and then like, it's kind of weird. But yeah, there's like more documentation on it. But yeah, definitely look through the tour of Go if you want to learn more about this stuff. Says this is like super interesting, but it's like honestly kind of long. It took me like a full week to get through it and like really understand it, but yeah.
How long have you been using Go?
Honestly, I would say since literally May. Not that long, so like since May.
You said earlier it's for your internship.
Mhm.
What were you using it for?
Again, like it's mostly back-end stuff, and I was working with like I'm trying to say this in a way that I actually can, but I was handling like routing, essentially writing systems that would route internal network traffic. And so again, like web stuff, you want to use Go for that. And
Like AWS, or was it just internal stuff?
it was just all internal stuff. It's all internal. But yeah, I totally recommend checking out the tour of Go. That one's very excellent, and there's much more information than I know. And so yeah, we can just go over a final example of like, just to show you how concurrency works, since this like blew my mind when I did this. But yeah, so we can just go take this, delete, I deleted all of main. We can also get rid of like the person struct. We don't need like a person. But then let's import time. We're gonna need import time on this one. And then we can just say, well, actually, here, let's create a function. Let's just say func, my func. It's my function. S string, again with the weird syntax where it's like backwards. And then you just want to say for I is equal to 0, we're setting it at 0, I is less than 5, I plus plus, emit the parentheses, and then time.sleep, 100 times time.millisecond, and then it's just going to give us, just sleep for a little bit, just sleep for a second, so it doesn't like just flood our screen, format.println, s, just print the string that we give it, right? So it's just going to go 5 times print the string that we want to see. And so now let's just say, again, this is how you start a Go routine in Go. You use the Go keyword, so let's just say Go, myfunc, world. Let's pass it this and say world, right? And then let's just call it again. Let's say myfunc, and this is the main thread, right? So this is going to separate, this is going to create like a separate Go routine with the keyword Go, right? And then myfunc, let's just say hello, say hello. And so let's just clean that up a little bit, save that, and then we can just run this. And you, actually, let me clear my screen. And then let's run this, and you can kind of see this is kind of how concurrency works. You can see hello, world, and like these things are running at the same time. That kind of changes every time because again, this is like dependent on your computer, I guess. But this is kind of how concurrency works. Hello, world are happening at the same time. It's printing at the same time almost. So yeah, that's just kind of like the example I wanted to show of that. And I can go back and like show the picture if that like helps a little bit more, since like this GIF like helped me a lot understand this. Like this GIF, where you have like your main thread and then you have a Go routine that you create and that you're able to like send stuff through the channels. And so yeah, that's honestly kind of everything I had. Do you guys have any like comments, questions, or concerns? Because I can also show the additional resources that if you want to like take a screenshot of this, since this is on the Notion page as well, but this is like the stuff that I use to learn. This is the tour of Go. This is just the blog, like Go's blog. So if you're interested in reading any articles about it, since like they kind of have like Medium pages and stuff, like new updates and new stuff that people are able to learn to do. And then there's also a whole Udemy course on how to learn Go. I know as UTSA students, I think we get Udemy for free, or we get some, huh? It's not Udemy? Okay, what did we get? We got Udemy for something. But yeah, there's like a Udemy course that's free, and then there's also, right here is the link to an MIT course on distributed systems, since that's kind of what this delves into. This lets you work a lot with distributed systems, and because concurrency, distributed systems, hand in hand. I don't know that much about it, but yeah.
Are there classes in Go or just structs?
Oh yeah, so this class is in Go.
No, I mean like OOP classes.
Oh no, there's no classes. It's just structs and like interfaces. There's no like classes.
Structs have methods, or do you use like a function outside to work on the struct?
I believe so. I believe so. Because I'm pretty sure I did use like a method in a struct, so I think that is correct. And yeah, there's also this exorcism thing. I don't know why it's called that, but that's pretty cool. And then here's like the cheat sheet at the very bottom. And so yeah, that's kind of like everything, everything that I had. So like, please don't forget to check in on the the portal page, or if you guys have any questions about anything, I can direct you to some stuff. Or you have any questions about what I did over the summer, then I can answer those too. But yeah, it's like a lot of stuff where if you know C, then you can pick this up very easily.
Is there like a QR code for the check-in?
Oh yeah, I can pull that up right here. There's this QR code. But yeah, honestly, like most of it's very similar to C, except that you don't have to do a lot of like the cleanup work. Like you don't have to clean everything up. There's no like just random stuff that, I don't know. There's a lot of built-in functionality that's really, really nice, and it's like, wow, I didn't even know you could do that, but I guess you can. So you know what? Might as well use that. So I would totally recommend doing this, and it's like as readable and easy to pick up as like, if you know C, you can pick this up essentially, and then it has the same like runtime efficiency despite being like a lot easier to work with and write. So I would definitely like look into this if you're interested in doing anything like that. But yeah, that's kind of everything I had. I know we're like 15 minutes early, so shoot. I'm trying to think, what else can we do now? You guys want to play GeoGuessr? You guys want to play GeoGuessr? But yeah, I don't really know how to end these things. Just like a thank you, please check out the resources that we have. And don't forget to check in and make sure that you're at your 5 attendance points for next semester. So yeah, let us know if you run into any issues like tech-wise. Like you can just go to email tech@acmutsa.org and someone will answer you. So yeah, thank y'all for pulling up to this workshop. Let me know if you guys have any other questions. I'm gonna post the code like online so you guys will have access to it as well if you did not get to follow along that much, but it just takes like time working with it and stuff. But it's like really nice when you are able to get it down, because like the fact that you don't even need to like use an interval. You can just have like an underscore and it's fine. It's crazy. And this stuff is also really, really cool. There's an OpenStax textbook on concurrency and like operating systems if you are interested in that as well, since that's really cool. I know they have like a distributed systems class at UTSA, but I don't think it's like as in depth. I think it's like more cloud stuff as well. But if you're interested in concurrency, like that textbook is really good. Oh, it's OpenStax. So it's like a free textbook online. If you're taking operating systems, I would totally recommend reading that as well, since it's good to know. But yeah, that's kind of everything I had. Thank y'all for being here.